In this lesson, we're going to talk about how to solve quadratic functions by graphing. By the end of this lesson, you should be able to solve a quadratic function by graphing and make connections between the x-intercepts, zeros, and solutions to a quadratic equation. Now, when we're talking about solving by graphing, the solutions are found by identifying the x-intercepts. So if we were going to look at a couple of examples, like here, where does the parabola cross the x-axis? If we know where it crosses the x-axis, and we also know its solutions. So here it crosses at -4, 0, and 3, 0. This next one we have -4, 0, and we have 4, 0. Here we have -2, 0, and +2. So our solutions for this third graph would be -2 and 2, because this is where it crosses the x-axis. When we're solving by graphing, the roots are the solution to a quadratic equation. So we have a couple different names for them. We call them x-intercepts, we call them zeros. The x-intercept refers to the ordered pair, where the zero refers to just the x value. When we're writing our roots, our solutions, we're writing our answer in braces, so remember that. There are instances where we have no root, and there are instances where we have a double root. Most of the time, we've got two solutions, and we saw that when we were factoring. In 90% of the cases, we have two solutions. That's when the graph crosses the x-axis at two spots. But we do have a double root. Okay, this is when you only have one solution. When the solutions end up being the same. A double root is when the vertex is the point that touches the x-axis. And then we have no root when your graph does not cross the x-axis. Now, the steps to solving using standard form. So recall in the previous videos we talked about how to graph using standard form. So remember, when we're graphing using standard form, we use the axis of symmetry. So we find that, which is -b over 2a. We find the vertex. Once we know the axis of symmetry, we know the x. We plug in the x, we get out the y. Make a table so that you have other points. Draw your parabola and then identify the roots where the graph crosses the x-axis. Now, our steps for solving using vertex form. Remember that in vertex form we're given the vertex. We pull h and k out of the equation. We make a table of values, again just like we did before. Get both sides of the vertex, draw your parabola, and then identify where it crosses the x-axis. So let's take a look at the following equation. So here we have x squared minus 8x plus 12. We want to graph this. So if we were going to graph this, remember that we're starting with the axis of symmetry, which is -b over 2a. Remember that a in this case is 1, b is -8, and c is 12. Remember, because we have a -8, when I put it into -b, it's going to change it to a +8 over 2 times 1, that was a. So that would be 4. So my axis of symmetry is 4. That tells me that my vertex is going to be 4 something. So remember, to get out my vertex, to get out the y-coordinate, I plug in my 4 into my equation. So it's 4 squared minus 8 times 4 plus 12. That's 16 minus 32 plus 12. Let's see, this would be -16 plus 12. So that would give me -4. So my vertex appears to be at -4, or at 4, -4. Alright, so again, we want to put our vertex in the middle of our table. I get 2 points that come before, 2 points that come after, and I substitute those in, so I'm just going to use 2. That's 2 squared, that's 8 times 2 plus 12. That's 4 minus 8 times, or minus 6, minus 16 plus 12. that would be negative 12 plus 12. That's 0. Okay, it should open up, so remember that because a is positive. It's positive x squared, so when I'm graphing it, make sure that it opens up. That also means 6 is 0. Alright, I plug in 3, so it's 3 squared minus 8 times 3 plus 12. It's 9 minus 24 plus 12. I believe that's 15. Negative 15 plus 12. Negative 4. Okay, so then I graph it. I've got 4, negative 4. I've got 3, negative 3, and 5, negative 3. I've got 6, 0, and I've got 2, 0. Graph it. Okay. Y-intercept is not super easy to tell here, but I could find it. We're going to find the y-intercept. I plug in 0. So 0 squared minus 8 times 0 plus 12. My y-intercept would be 12. My roots in this case, when we graph, are at 2 and 6. Remember that goes in braces. And there is my solution. If we look at this next one, again, we're solving by graphing. So we need to start by finding the axis of symmetry. So negative b over 2a. A is 1, b is negative 8, or negative 4, and c is 6. So that would be, again, because I'm putting in a negative, that's positive 4 over 2 times 1. That would be 2. So my axis of symmetry is x equals 2. So I wrote x equals this one. Okay, x equals 2. On my vertex, again, plug in the 2, substitute that into the equation. So that's 2 squared minus 4 times 2 plus 6. That's 4 minus 8 plus 6. That would be negative 4 plus 6, which is positive 2. So my vertex is 2, 2. Again, my vertex is going to be minimum because this parabola should open up. Since a is positive, put that in. And go ahead and find my y-intercept, 0, make that 0. All that would be left is the c, so that would be 6. 0, 6. And then all that's left is to graph and find where it crosses. So if I'm looking at this one, again, I'm going to look at 2 points that come before. I've got 1 and 0, and thankfully I already found 0. I've got 3 and 4. Alright, so all I have to do is find out what these 2 points are. So 1 squared minus 4 times 1 plus 6. That's 1 minus 4 plus 6. This would be negative 3 plus 6. So this would be positive 3, and this would be positive 3. So I go to graph. I've got a point at 2, 2. I've got a point at 1, 3. I've got a point at 3, 3. I've got a point at 4, 6. And one at 0, 6. This one, if you notice, because it opens up and because it does not cross, there are no roots. Alright, here we have an equation in vertex form, so I'm going to go ahead and add the part that's missing, right, my k. Remember, it's hk, we do not include the negative. We're pulling out the vertex. Because this is a positive 2, it means that h is negative 2. And then k is 0. So my vertex is at negative 2, 0. My axis of symmetry is at x equals negative 2. It shares the same x as that. So then all I have to do is figure out what these other points are going to be. So negative 2, 0, this would be negative 1, this would be 0, this would be negative 3, this would be negative 4. I'm going to use 0 and negative 1. I've got negative 0 plus 2 squared plus 0. Well, that's going to be negative 2 2 squared is 4, and make that negative, that's negative 4. So for 0, I've got negative 4, negative 4. So that tells me my y-intercept is negative 4. This one, again, will open down, so my vertex is going to be a maximum this time. And then let's find negative 1. So we get negative 1 plus 2 squared plus 0. I don't really need the plus 0 at this point. Negative 1 plus 2, that's positive 1 squared, that's 1. That would make a negative 1. So we put negative 1, we've got a point at negative 3, negative 1. And so we graph this one. We've got a point, again, at negative 2, 0. Should open down, so negative 1, 1. And then I've got 4, negative 4, 0, negative 4. Graph this one. I see that where it crosses is on the vertex. This would be a double root. And my solution would be just one number, and that would be negative 2. Alright. An art gallery has walls that are sculpted with arches that can be represented by the quadratic function, where x is feet. Wall space under each arch is painted a different color. Alright. We would graph, in order to solve this one, you would graph the quadratic function to determine its intercept. So remember that if we're graphing in standard form, find the axis of symmetry, negative b over 2a. Use that to find the vertex. And when we graph, we should end up with a graph that looks something like this. We see that our roots in this case would be 2 and negative 6. And then the distance between those two segments would be 8. So you would count the numbers, you'd count the gap between the two segments. Alright, this is how we solve quadratic functions by graphing.